Okay, think about everything we can see out there in space. Every single star, every planet, every galaxy. What if I told you that all of it is just a tiny, tiny fraction of what's really out there? Today, we're going to pull back the cosmic curtain and explore some absolutely incredible secrets that, well, they challenge our very understanding of reality itself.
And we're going to start with just one number, a really staggering one, 95%. I mean, just let that sink in. 95% of our entire universe is completely invisible to us. It's made of stuff we can't see, we can't touch, and we can't directly observe. So the big question is, what is all this missing stuff?
And that question brings us right to our first huge mystery, the unseen universe. I mean, what is this invisible majority that completely dominates the cosmos?
So, first up, you've probably heard of this one, dark matter. The easiest way to think about it is like it's the universe's invisible glue. We can't see it at all, but we know it's there. How? Because of its insane gravitational pull. Seriously, without dark matter, entire galaxies, including our own Milky Way, would just fly apart. So we know it's there, we can see its effects, but actually finding it, that's one of the biggest quests in physics right now.
And then you've got its equally bizarre counterpart, dark energy. So if dark matter is the glue holding things together, dark energy does the exact opposite. It's this mysterious, repulsive force that's pushing space itself apart. It's the reason the expansion of our universe is actually accelerating, speeding up over time. And what it is, honestly, it's almost entirely theoretical at this point. Okay, so we've talked about the 95% we can't see. Let's shift gears now. It's time to dive into the 5% we can see. And trust me, it's just as wild. In this section, Extreme Objects, New Worlds, we're going to explore some of the most awe-inspiring and, yeah, sometimes terrifying things we've actually managed to find out there.
And this kind of raises a chilling question, right? If the vast majority of the universe is hidden, then what kind of monsters are lurking in the little bits of darkness we can actually detect?
Well, at the very top of that list has to be the black hole. These things are born from the collapse of massive stars, and they're basically points in space-time where gravity gets so ridiculously strong that nothing, and I mean nothing, not even light, can escape.
And this is the critical part. It's the point of no return, what we call the event horizon. It's not like a solid surface you could touch or anything. It's just a one-way boundary in space-time, and once you cross it, well, turning back isn't just hard. It is physically impossible.
But hey, it's not all terrifying voids and points of no return. Far from it. Beyond all that darkness, we are living in an absolute golden age of discovery. We're finding thousands and thousands of new worlds. We call them exoplanets, and they're all orbiting stars way, way beyond our own sun.
And this, of course, has kicked off one of the greatest quests in human history, the search for life. So what do scientists do? They focus on planets in what's called the habitable zone, that sweet spot where conditions might be just right for liquid water to exist. And then, using these incredible tools like the James Webb Space Telescope, they act like cosmic detectives, analyzing the light that passes through distant atmospheres, hunting for what they call biosignatures. These are the little chemical fingerprints that could, just maybe, point to life.
Okay, so this brings us to our next big idea. We've talked about what we can and can't see. But what about what we can hear? How do we actually listen to the universe? How do we tune in to those cosmic whispers that might just hold the answers to everything? Well, one absolutely revolutionary way is through something called gravitational waves. Get this, Einstein predicted them over a century ago, but we only first detected them in 2015. These are literal ripples in the fabric of space-time itself, usually caused by something insane, like two black holes colliding. For the very first time, we can actually hear the universe's most violent events.
But there are other cosmic whispers out there too. For instance, you've got gamma-ray bursts. These are the most powerful explosions in the known universe, releasing more energy in a few seconds than our sun will in its entire 10-billion-year lifetime. We're pretty sure they come from massive collapsing stars. But then, you have these things called fast radio bursts. These are super intense, millisecond-long flashes of radio waves, and honestly, we have almost no idea what causes them. It's one of the biggest head-scratchers in astronomy today.
So let's kind of put all of this into perspective for a second. Our understanding of the cosmos is really on a spectrum, right? On one end, you have things like black holes. We've got a good handle on them. We've even taken pictures. Then, in the middle, you've got dark matter and dark energy. We know they're real because we see their effects, but we don't know what they are. And then way over on the far end of the mystery, you have stuff like those fast radio bursts, where we're still just trying to figure out what's even making the signal.
And all of this, it brings us right to the very edge of our knowledge. When you're faced with so many mysteries, from the invisible stuff to these bizarre, powerful explosions, you're forced to start asking the really, really big questions.
And where else do you start but at the very beginning? The Big Bang Theory. It's still our best scientific explanation for how everything began. The idea that 13.8 billion years ago, everything in existence just exploded out from a single, super hot, super dense point. And the proof isn't just buried in some complex equations. It's literally all around us, right now. It's this faint glow in the sky called the cosmic microwave background, like a fossil, a faint echo of that very first moment.
But what if our universe isn't the only one? This is where things get really wild. The multiverse theory is this completely mind-bending idea that suggests our entire cosmos, everything we know, might just be one bubble in a massive, churning sea of countless other universes, and each one could have its own unique laws of physics. For some scientists, it's an intriguing way to explain why our universe seems so perfectly, almost impossibly fine-tuned for life to exist. And that fine-tuning for life, it leads to a really haunting question. It's called the Fermi paradox. I mean, think about it. With trillions of planets in our galaxy alone, the odds say the cosmos should be absolutely teeming with life. It should be loud. And yet, all we hear is silence. It begs the question, where is everybody?
But, even our best theory, the Big Bang, has its limits. It does a great job of describing what happened after that first fraction of a second. But what about the instant before? What happened before the Big Bang? What, if anything, was there before time and space even existed? And the honest answer is, right now, physics just stops. We don't have an answer. And just like we have to ask about the beginning, we also have to wonder about the end. What is the ultimate fate of our universe? Will that mysterious dark energy keep pushing everything apart until it's all ripped to shreds, leaving just a cold, dark void? Or could gravity somehow win in the end, pulling everything back together into one final big crunch?
And honestly, that's what makes all of this so exciting, isn't it? It's a truly endless cosmic quest. It seems like every single time we find an answer to one of these huge questions, it just opens up a dozen new ones that are even bigger and even deeper.
When you boil it all down, our whole journey through the cosmos is driven by just one thing, plain old human curiosity. It's that insatiable need to know that pushes us to build bigger telescopes, to dream up crazier theories, and to just keep looking up at the stars and asking that simple question, why?
So, I'm going to leave you with one last thought to chew on. It's a question that connects the biggest monsters in our universe with its deepest mysteries. What if the end of a journey into a black hole isn't an end at all? What if it's the beginning of a brand new universe?